Okay, so I got a good question about expected value with empirical probabilities. Here we have a salesman, Sam, who has worked for 400 days, and he's kept track each day of how many new clients he's obtained. And he's got the data recorded in the table below. And we're asked to figure out um, if the future holds kind of the same as the proportions that they have in the past. Which of the following statements will be true? So the first is the expected value of new clients that Sam's obtains in one day, rounded to the nearest hundredth. Now, remember, the expected value is really just the average of what you got in the past. Okay, and so what we could do is we could add up 153 times, 110 times, 77 times, 39 times, and 21 times. Add all that stuff up and divide it by 400 just to get the average. Fortunately, we've got multiplication, right? So we can speed that up just by saying, well, 153 times 1 is 153 ones. 110 twos times 2 is going to be the same as having 110 twos, so on and so on. And then just dividing by 400, like we said before. The total of the numerator is going to be 865, and we divide that by 400. We get 2.16 approximately. That's not equal, it should be approximately. But that's rounded to the nearest hundredth. So we're going to say yes on A. Okay. So now we just have to go and see if the second statement's true. Sam is most likely to earn 2 new clients on the next day he works. Well, we expect the expected value is a little over 2, but he never actually earns 2.16 clients. He's going to earn one of the other ones. So we look at the probability, and it's most probable is he's going to get a 1, right? Because on 153 days, he got 1. Okay. So that's the most likely outcome for the next day is 1, even though expected value is 2.16. So this is not true. Sorry. In the long run, Sam can expect to have days where he obtains 2 clients more than 5 times as often as days where he obtains 5 new clients. So here we just have to get the frequency. So how many days will he get 2 new clients if the future is like the past? Well, the proportion of times he got 2 clients was 110 days out of 400. So I just calculate the probability, and that's about 27. That is 27.5% of the time. And how many days did he get 5 clients? Well, that was 21 out of 400. So that's about 5 or that is 5.25% of the time, a little close to 5%. Now all we have to do is multiply the frequency of 5 days and see if that is as much or more than the 2-day frequency. And I multiply that and I get 26.25%, right? In the long run, Sam can expect to have days where he obtains 2 clients more than 5 times as often as he has days where he can obtain 5 clients. And that's true, right? This 27.5 is more than this 26.25. Okay. More than 5 times as often. Over the next 5 days that Sam works, he can expect to obtain a total of 12 new clients. Well, over time, you expect the expected value for each day is 2.16. So all we have to do is just multiply the expected value times 5. And that's 5 times 2.16 or 10.8. So we're not really expecting Sam to get 12 new clients. We'd have to say false on that one. Hope that helped.